Good morning. You are welcome to today's mathematics class. My name is Taiwo Osia. This morning we want to look at a topic, a very important topic in mathematics, and that is differential calculus. Differential calculus. This topic comes to mathematics as a result of the study of the rate of change of one variable with respect to another. So, such as the rate of change of salary with respect to time, and so on and so forth. So, this rate of change of one variable with respect to another leads to the study of this aspect in mathematics, which is called differential calculus. And looking at this function, y equals to f of x. In differential calculus, this y is dependent variable, and x here is independent variable. So, we want to look at a very important thing under differential calculus, and that is differential coefficient. Differential coefficient. Differential coefficient is defined as the limit as theta x tends to 0 of theta y over theta x. This is the definition of differential coefficient, and it is denoted as dy dx. Sometimes it is also denoted as f prime of s or y prime. So this is what is called differential coefficient of a function, denoted as dy dx. So, very quickly this morning, we want to look at differentiation from the first principle. Differentiation from the first principle. Differentiation from the first principle. The process of finding differential coefficient, which is dy dx, is what is called differentiation. The process of we finding this differential coefficient is what is called differentiation. Now, looking at differentiation from first principle, the function y equals to f of x is the one we are using here. And we add little changes in y and little changes in x, which is called theta y and theta x respectively. So when we add changes in y to this side and changes in x to this side, we have y plus theta y equals to f of x plus theta x. Don't forget what we are finding, because we are differentiating from the first principle. That means we are finding the differential coefficient, because the process of finding differential coefficient is what is called differentiation. Now, we want to find something of the form theta y over theta x. So we need to take this y to this side now, so as to have only theta y here. By the time we take y there, we have theta y left here, and is equals to f of x plus theta x minus y. Don't forget that our y here is f of x, so we can replace, instead of writing y here now, we can write f of x, and we now have theta y is equals to f of x plus theta x minus f of x. So with this one now, we have our theta y here now. But you can see that it's divided by delta x, so we can introduce that here on both sides. Because I want to have delta x here over delta x here. And whatever I do on one side, I must also do on the other side. So divide both sides by delta x here. This particular equation will become delta y over delta x equals to f of x plus delta x minus f of x, everything over delta x. Now, we already have our delta y over delta x. And from the definition of differential coefficient, this is what we have. So what it remains for us to introduce now is the limit as delta x tends to 0 on both sides. So when you introduce that now, limit as delta x tends to 0 of delta y over delta x is equals to limit as delta x tends to 0 of f of x plus delta x minus f of x all over delta x. Now you can see that what we have on the left hand side here now is called the differential coefficient, which is our dy dx. So therefore, from the first principle, our differential coefficient, which is dy dx, is now equals to limit as delta x tends to 0 of f of x plus delta x minus f of x over delta x. So this is, differentiation from the first principle. This is called differentiation from the first principle. Anytime we are differentiating from first principle now, this is the formula we use. So let's look at one example. Differentiate y equals to s squared from the first principle. Solution. So we have to differentiate y equals to f of x, and that is y equals to s squared from the first principle. Don't forget, from the first principle. And this formula will come to our mind now. That is, from the first principle, our differential coefficient dy dx is given as limit as delta x tends to 0 f of x plus delta x minus f of x all over delta x. So this is the formula, and this is the function given y equals to x squared. When you compare this y is equals to x squared to the function we have, which is y equals to f of x, here you can easily say that our f of x will be s squared. We can easily say that our f of x is s squared, and when you add the delta x, you change the x, we have f of x plus delta x. We now become, add delta x here now. You will add it before you put the square. That's x plus delta x, then square. So we have that now. Now substitute this back into the formula. Our dy dx now becomes limit as delta x tends to 0 of f of x plus delta x is now x plus delta x squared. X plus delta x squared, then minus f of x. Our f of x is s squared, then over delta x. So by the time we solve this now, simplify what you have here, it will become limit as delta x tends to 0. When you expand this bracket, in a very simple bracket to expand, it becomes s squared plus 2x delta x plus delta x square minus x square all over delta x. So by the time you look at this, you can see that x square minus x square cancel out. So what we have left now is limit as delta x tends to 0 of 2x delta x plus delta x square over delta x. Now easily we can say delta x cancel delta x here, also delta x cancel 1 delta x here, because these two fractions here now are divided by delta x. So what we now have left is limit as delta x tends to 0 of 2x plus delta x. Now limit as delta x tends to 0 means anywhere you see delta x now you put 0. So therefore our dy dx is now 2x plus 0, which is finally what? 2x. So our differential coefficient dy dx is now 2x. So differential coefficient of y is equals to x squared for the first principle is finally 2x. Thank you for listening. Do well to subscribe to this channel and join us next class. You can turn on your notification so that anytime we upload video on any class, like important class like this, you'll be able to watch. Thank you. Have a nice day. God bless you.